In this episode, we're going to take our single room and spawn multiple copies of it to create a full level. And then we're going to connect all those rooms together with our doors using a maze algorithm, which is something I don't think many people have done in Blueprint and certainly not in PCG. So open up your project and let's get started. To turn this room setup we have into a full level setup, we're going to start with a blueprint. Add a blueprint class here. It's just going to be an actor. Call that BP level. And we're just going to use that to define some parameters for our rooms that will spawn in. So we don't really need to add much to this. We just want to add a PCG graph. So let's add that. So let's go ahead and create that. And we'll call this PCG level. That way we can add that here. So inside of BP level, we're going to add a couple of variables for now. Add floor mesh, which is going to be a static mesh, object reference. And we'll do the wall mesh as well. We may end up replacing these later with a data table reference or something, but for now this will help get us working. Having the floor mesh here will let us determine the size of the floor mesh. We did that in our construction script for our BP room. We got the bounding box of our floor mesh, and we're going to want to do the same thing in our BP level. So I am just going to copy this over, and we're going to go in our construction script and we'll add this in. Create a matching function for this room size odd, because we're going to want to make sure our room sizes are odd here as well. So we'll go in construction script, check our room size is odd, check our floor mesh is valid. If it is, we get the bounding box and we determine our cell size. Perfect. We want to create the variable cell size, and then from that cell size and from our room size, which we need to make as well, create room size, we will set up the room extent. Okay, perfect. So we want to make this room size XY visible as well as our floor mesh and our wall mesh. Compile this, make sure that works. Oh, we don't have room extent. Let's create that variable. We need to make that visible as well. And also our cell size, we're going to need that in our PCG graph, so we'll need to make that visible. Let's go ahead and set up this room size odd function that's going to be the same as it is for BP room. We can copy this over. Compile and save. Then let's go out to our level and we'll go ahead and remove all these rooms. Just going to remove everything from this level. Be right back. All right, so I got all that stuff cleaned out. Now I just have the lighting, player start, and normal stuff. So now I'm going to drag BP level in here. And I'm just going to put that at 0, 0, 0. Don't really need to, but just for convenience, I'm going to. Now we want to open up PCG level, and we'll start building that. So inside of our level, let's go ahead and set our floor mesh. We want to use SM floor and our wall mesh, which was SM wall. Then our cell size should set automatically. For a room size, I'm going to set 9 by 9, which automatically sets our room extent, and then we'll be ready to go into our PCG level. Inside of our PCG level, we're going to set up a points grid. And for this points grid, we want to override our grid extent and our cell size. We want to use get actor property here, and we're going to get that cell size that we calculated. And I like to rename these two to the property that they are. Makes it more clear when you look at the graph. So let's set that cell size, and then we need to also calculate our grid extent. For this setup, we can actually calculate that. So let's go back into our BP level. We calculated, we don't have a number of rooms yet, so we want to set a level size. I'm going to call this level size XY. For that level size, basically that would be number of rooms in the X and Y direction. Make that a vector 2. Make that visible, and then let's get that level size here inside our construction. We have our room extent right here. We have our level size. So we want to do a similar thing to what we're doing right here. We have our cell size. So in this case, we're going to get our room extent, split that. We're going to split our level size. and multiply the x by the x and the y by the y. That'll give us our level extent. So let's add a new variable, level extent, and we'll want to make that a vector, not a vector 2, because it's going to be expecting a vector. And we'll set that here. So let's set these the extents to 1. That way we don't end up with a division by 0 error. Now we have our level extent, so let's get that here. Again, get actor property, property name level extent. Oh, need to make this visible here. There we go, now that error went away. Set this name. And that's going to be our grid extent. Now let's just take a look at that. Turn our inspect on. Oh, I don't have a size set for the level. Of course, level size. All right, let's say we want to do a 4x4 grid of rooms. Okay, and there we go. Now we have the start of our data, except our cell size should be our room extent, not our cell size. Sorry about that. Get actor property. Property name is room extent. Okay, and then on our create points grid, we need to make sure we uncheck call points outside of volume because we're not using a volume. And there we go. Now we have our points generating correctly. So now let's turn debug on for that. And let's debug by extents with the PCG cube. The default bounds on that is -1 to 1, so they're very small. So before we take a look at those points, we're going to need to make that bigger. Let's use on extents modifier. And we want that extent to be our room extent. And then we'll debug this one instead of this one. And now we see something. And what we're seeing here, it looks like a solid plane, but what we're actually getting is the extent for multiple points here. If we take a look at our tripod instead, on this one, tripod, we see we have a grid. So at each of those grid points, we are going to spawn a room now. In order to create our rooms, instead of using spawn actor like we might think with a BP room, we actually want to use a subgraph and call our PCG graph in our BP room directly. We're already doing everything that we do in the construction script and our room size odd. And there's nothing in our event graph or viewport that we need from BP room. We're already doing everything we need in BP level. So we can just directly access this PCG graph that we created for PCG room. So let's go over to that and let's actually make a copy of this. The reason I'm making a copy is because we'll probably need to make some modifications to this for the level, and we may still want this PCG room to function correctly inside of the blueprint. And then inside our PCG level, we're going to add a loop subgraph. And for that graph, we want that PCG room 1. Using this as a subgraph allows us to set inputs here, and we can set everything that we're setting for BP room. These items here, we can pass through more easily this way as a subgraph. So let's go into that graph. Currently, we're taking our room extent, cell size, floor mesh, all these parameters as a get actor property. And instead of doing that, we're going to want those to be an input. So in our input node here, we can add custom inputs. So let's add a custom input for room extent. And that's going to be an attribute set. And we don't need to take multiple data or multiple connections, so we can unselect that. Then we're also going to take our cell size. That's also going to be an attribute set. No multiple data. We'll also be taking in the floor mesh and the wall mesh. And same thing, attributes and no multiple data. Now we can replace these connections with the new connections. Here's our wall mesh up there. And then down here we also have our room type. Let's go ahead and add that as another attribute set. And we also have that over here and up here. We'll make sure that gets set in all those locations. And then we should be able to pass in the parameters that we want. So now we see we have those parameters available here. We have our room extent. We can just drag over. We need to get our cell size. And we need to get our floor mesh, wall mesh, and room type. Actually, we don't get room type. Room type we're gonna set with a random. So if we go out to look at our level at this point, we'll see we have one room, which means things are working, and that room is the correct size. It's of a library type, which is kind of our default type, and that's it. There's nothing else on the level. The reason we don't have anything else here, we go back to our PCG level in our loop subgraph, we are not passing in this point grid that we're using, and we're not looping over that point grid. So what we want to do in our loop subgraph here is we want to change this room extent. We want this to be points instead of attributes. And the reason for that is that we're going to pass this points in instead of that room extent, because this includes our room extent. So now we can loop over room extent. Loop subgraph is actually set up to loop over sets of data, not points of data. And we're looking at points of data here. So we want to separate these points out into separate sets. We can do that with an attribute partition. And we'll take our point set into that, and then we'll go into the room extent. And we want to partition, we can just partition on index. If we look at it, make sure we have this selected up here. We look at our input, we have index, and this is actually $index. But for whatever reason, it doesn't allow us to access that attribute. But what we can do is we can use a copy attribute here, and we can copy from $index to index and use that instead here. And now, instead of having one set of data here with lots of rows, we have lots of sets of data here with an individual row. And that's what we want for our loop subgraph. I'm going to move this over, put this copy attribute up in here. So now we have changed the format a bit of what we're passing into room extent. Instead of passing in just the size of the room, we're passing in this whole line of data here. Originally, we were just passing in the X and Y bounds, but now we're passing in position, bounds, and all this other stuff. So we got to go into our graph and see we have an error here on this break vector attribute. And that's because that's expecting just this room extent to come in with a vector, an X and a Y, and that's all. So we need to change how we're doing this grid extent right here. And to do that, we want an attribute select instead. So we're going to move this up here to this attribute select. And what we're going to select here is our bounds max. And we want that bounds max to be the minimum on X. This is correct down here. And we want to output that to grid extent. And then we can take this out as an attribute and run it directly into our grid extent. So now we want to run that also into the other places where this was running. And we take a look at that, and we have our room. It's not quite correct, but it is pretty close to correct. The other thing we need to change is this create points right here is creating a point that we copy the room to. And when we had one room, this 000 point was correct. But now we're creating multiple rooms. And so we want to use this room extent here, which includes the position data for our room. We want to use that as the point instead. So let's create that as the target, and we'll put that into all of our centers. And we'll get rid of this create points. So in our inputs, this room extent needs to allow multiple data. Now you're going to see it rebuild the rooms, and we're going to come in here with all our rooms built. So now we're getting somewhere. Let's do a save all. When I set up the level blueprint here and set this level XY, my intent was to have this 4 go from 0 to 4 in one direction. But if we look at our grid here, we can see that what we're actually getting, and if we look at this output from our create points grid, we can see that our extent here is going to 6300 positive and 6300 negative in both directions. So we're getting that in both directions, not just one direction. So what we actually want for our level extent in our BP level is half of this. So what I'm just going to do is just divide this by 2. So now if we look back at our create points grid, once we get this refreshed, is we can see here that now we only go up to 2700, and if we look back here at our output grid, we see 4 points. So if I turn this loop subgraph back on, which I disabled for testing, and regen this level, we now see we actually end up with 5 rooms instead of 4, because we're going from 0 to 4 essentially instead of 1 to 4. So we have a 5 by 5 grid of rooms, which is essentially what we want. So now we need to figure out what's causing this error here, with these walls sticking out like they shouldn't be. It's funny how sometimes data related errors can crop up like this, and you can go along and everything's working fine and perfectly, and then you expand your data set and you end up with something like this. So what's actually going on here is when we make this bounds max into the grid extent, we look at our output here, the Z value ends up with a value, and this should actually be 0, but because the bounds has to have some value there, it's going to end up with some value. And then when we come down here, we go into our get corners, which uses the half extent. If we go into this get corners, we just directly use this half extent in the positive X and Y. So as a result of that, we end up with a Z. And this one's not showing as having that positive value, but some of them do. So I go back here, if we find the right loop, we'll see that this get corners comes out. So we've got this 0.05 right here on this position, and this is causing a minor problem in our create spline, where we go down here and we have this Z position variance. And that causes occasionally our wall to be off just enough to create this extra wall here. So if we get rid of that, here in our get corners, we only want an X and Y here. So if we just do another make vector attribute here, and instead of using this input directly, we use the X and Y value of that input. Once that's corrected in this get corners, go to our PCG room 1, and now we look at this create spline value, and we see no more position Z values. So we should go back out here to our room, and boom, all of those are fixed. So now we have this grid generating correctly. So for our room extent, rather than running this extent directly in here, we actually want that to be half of this extent, because the extents modifier is going to go in both the minus and the plus direction. So we can use our subgraph here, and what we want for that subgraph is the PCG half that we created way back when, to divide that number in half. And that's going to be our extents for our extents modifier. Now that we've made those corrections, we are getting the correct number of rooms. This is a 3 by 3 grid. We're getting 3 by 3. If we go 4 by 4, we're going 4 by 4. So actually before it wasn't getting extra rooms because we were going from 0 to 4, but rather because our extents were the incorrect size. So it was creating overlaps that made more rooms than it should have, and actually slowed things down quite a bit because of those overlaps as well. And now our walls are all lining up correctly. This is all working to create our rooms. Now what we need to do is randomize our room types and add in doorways between these rooms. There's a few different ways that we can set up the doors. I'm here in PCG level. I think the easiest way to do this is going to be to use a maze generation algorithm to add to this set of data after the points are generated for the rooms, then add the doors in to this point data. And so the way we're going to do that is right here after we create this set of points for the rooms, then we'll create a new function here to add the doors. So in our content browser, let's create a new blueprint class, and that type will be PCG blueprint element. Select that, and we'll call this PCG BP add doors. Then inside our PCG BP add doors, we want to set up the same default functions that we used previously. We want an execute with context. And that should be all we need. I'm going to open up our PCGBP room props. And from this execute with context, I just want to get same thing we did previously and copy it over to add doors. So we got the context. We want that. I'm going to copy this stuff over here, the get typed input by pin label and this context, and just copy those over to the new execute with context. Make sure you create this variable. And that just saves us a little setup time. I think I'll also copy over this setup for the output because that's going to be the same as well. Paste that in here, and then our outputs are ready to go with the collection. I think we can actually do this without the point loop body. So I'm going to remove this. In our class defaults, we want to check expose to library so that we can find this. And then let's give this a category as well. And let's go ahead and just give it a level category. We want to add this custom input pin. We want endpoints, which corresponds to our pin label here for our typed input pin. We'll call that endpoints, and we're going to allow type of point, and we're not going to allow multiple data on that pin. That way we can just get a single set of data in here, because in our PCG level, that's what we're creating here. We're creating this single set of data, and we're just going to manipulate this. We need to compile it. And here under level, we find add doors. We see our endpoints here. We can connect this up, and we will have an out points here that will connect up to copy attributes later. But for now, this is fine. Save this. Then we'll go back into our add doors and we'll get this set up. From our type data, this is going to return an array of PCG point data object references. So we need to get the first element of this, get a copy, and we just want 0 because we only allowed one set of data. And then from this, we want to get our actual points. We're going to use get points. So this is our whole list of points. And from that, for now, we only need the length. The way that a maze algorithm works is we want to start with a random room, and then we want to go to an adjacent room that we haven't visited yet. So we're going to start with a random room. So we're going to get the length of our points, and then we want to get a random in range. Random integer in range, and this is going to be our max value. We're going to go from 0 to max, and then from this point here we're going to do a get point. Actually, we don't want to get this point yet. All we need is this index right now. Index is the room that we've just chosen. We need to set up a couple of local variables here. We need a visited. Visited is going to be a Boolean. It's going to be true or false, whether we visited a room or not. Default's going to be false, but this needs to be an array. With this visited array, let's drag this out and get it. Then we want to resize that array, and we want to make this the same size as our length. That way we have an initial unvisited state to all our rooms. So then we can set array element that is our current room, and we can set that to be visited because we're going to visit this initial room. How this maze generation algorithm works that we're using, we're doing a depth first algorithm. We're going to need a stack. Add a new variable here called stack. And stack is going to be an array of integers. Because of how arrays work in Unreal, we can treat this as a stack. And make it a little more clear, we're going to add a couple of macros. To access this, we're going to add a push, and push will be adding something to our stack. And we're going to add a pop, which will be removing something from the stack. When we push something from the stack, we're going to need our stack. It's going to be our integer array. And then we're going to need the value, just a single integer. And then we need an exec pin. Let's put that up top. With our stack, we're just going to add. And we just want to add this value, exec through, add that to our outputs. And then we can also output this index. And that's all there is to push. Then for our pop function, we want to add an exec pin in our stack. From our stack, we want to get last index. This last index. And then we want to get that. And then we can promote this to a variable. And then we want to remove this index. And then we just want to return our value. All right, so now we have a push and a pop macro. We can go back to our execute with context. So in our execute with context, when we've picked this initial room, we want to push that onto the stack. We'll get our stack and then we'll push. And we're pushing this value right here. Let's comment this here. Let's pick random initial room. File and save this. And then before we go on to the logic of dealing with picking the next room, let's add a new custom input pin here. And this input pin is going to be max XY. This is going to be an attribute set, and it's not going to take multiple data. File this and save. And then we'll go back out here to our PCG level. Now we can see max XY is here. And for that, we're going to get the actor property, and we want to get our level size, XY. And then we'll feed that into here. Save this, go back into add doors. We want to get that as well here. Max XY here. We're going to do the same thing as we did here. For this other parameter, we want to get the maximum X and Y for rooms. And we can do that by just creating a variable here. We'll call this max XY. We'll make this a vector2, vector2D. We'll set this as visible, compile and save that. And when we go out to our PCG level, max XY is visible here, and hook up that level set XY to max XY. Now back in add doors, I want to promote this length to a variable. We're going to call that max index. So then we want to take our stack out, get that, and we want to do a while loop. And for our while loop, we want to do that while this length of our stack is greater than 0. That means when there's items in the stack, we will continue doing this loop. So inside this loop, we want a new function, call it visit room. So inside visit room, we want to pop the current item off the stack. Then we're going to want another function here. I'm going to call this function find neighbors. For visit room and find neighbors, we're going to need our points. So let's go ahead and promote that to a variable as well. Call that room points. Go back into find neighbors. Oh, and I made visited local. So let's go ahead and change visited to a regular variable. We'll call it is. And that's a Boolean array, and we'll just replace this. Replace these references here. Here, visited. Now back in find neighbors. What we want to do, want to get the current room here. So we're going to call find neighbors. Neighbors needs to know our room index. It's just going to be an integer, not an array. With that room index, we can calculate the north, south, east, and west neighbors. I'm going to set up some local variables here that are just going to be integers. And we'll just call them north, south, east, and west. We're going to pull all those out and set them. So our north neighbor is going to be our current room index minus, we'll use our max XY, and we're going to split that. I just want to truncate these. Probably should have set that up as an integer instead of a float. The vectors do is very convenient. All right, so there is our X and Y as integers. All right, so we're subtracting X off of the room index, get north. Then we're going to add it to get south. And for east and west, we actually don't need our max Y. For east and west, then we just want to add 1, subtract 1. Actually, I don't think I want to set those to variables this way. We're just going to end up getting rid of those. Instead, we'll create each of these. We've got north, south, east, and west. But then we want to check if they're in a valid range, because it's possible, like, let's say we're in room 1 and we just subtracted 4 from that. And this is room -3, and that's not a valid room. So we'll just discard that. There's no possible north. So let's check if each of these are valid. And I think we'll create another macro for that. It is valid, probably a better name for that, but that's all I can think of right now. And for is valid, we want to take an index in, and we want to test that. It has to be greater than 0, and it has to be less than our max index. Let's and that. We want both of those to be true. Then we'll just go back to find neighbors. We'll pull out is valid. And we'll test each of these. Actually, I think we can test if it's valid, and then we want to branch. If that is valid, then we're going to check if it's visited. We want to get that is visited, and then we want to get copy. And now we know this is valid. We can test it. And if that's also true, we'll branch again. And then let's have a variable here, local variable unvisited neighbors, which is an integer array. Get that here, and we'll add, we want unvisited, and false, we'll add this to that array. So we want to do that for each of these four, and we want to do that if either this fails or this fails, we want to continue on to the next one down here. So what we're going to want to do here is we're going to add a sequence. And we're going to do this sequence 4 times. So on 0, we'll do this one. And then on 1, we're going to do this one down here. And so we're going to be doing this same thing for each of these. We can go ahead and collapse this to a macro. Call this add visited. So, and these are both actually indexed. So get rid of one of them. Oops, add unvisited. All right. And then we can just copy this 4 times and hook each of these up. And then let's add one more pin to our sequence. And that's going to be our return node. And what we want to return here then is our unvisited neighbors. File and save. Now we have find neighbors. Go back out to visit room. And in visit room, the first thing we want to do is find those neighbors. We can rename this to find unvisited neighbors. And we'll pass this value in. So we want to get the length of our unvisited neighbors here. This is greater than 0. Then we are going to push the current room back onto the stack. Actually promote this to a local variable here. We'll call this current room. On true here, we want to push that current room back onto the stack. Then we want to get a random in range. Our length is our max value here. The index is to this array. We want to take this array. We want to get a copy of this room. So this is our neighbor that's not been visited yet that we're going to go to next. And so we want to push that onto the stack. Then we need to set a doorway between those rooms. Oh, so it looks like I lost the variable create that unvisited neighbors. Now that should be corrected. In order to add that door in, we need to know what direction that this room is related to our original room. One thing we need to correct here is when we're coming out of find unvisited neighbors, we're getting the length of our array, which is correct to test this branch here to see if there are unvisited neighbors, because we want to check the length of the array. If the array length is 1, then it'll be greater than 0. That means there is one item in there. However, in that case, this random integer in range is actually incorrect, because it will go from 0 to 1, but it needs to go from 0 to 0. And what we need here, instead of length, break that, and then we'll get last index. The last index will give us the correct value for our range, and length will give us our correct value for our branch. So in our execute with context, where we get our points, we're getting the length of that array. Then we're setting that as max index, but what we want to do is get the last index and set that as the max index. And that is also the correct value for our max for our random integer in range, because this is our index values. We want the last index. And then for the resize, we do want the length, not only our is visited array. So let's go back to our add unvid. We want to add another variable here, but we're going to need to create an enumerated type for that. So let's go back out here to our content, add a new enumeration. Blueprint enumeration. We'll call this E direction. And in direction, we're going to add a north, south, east, and west. Save that. And then back in PCG BP, add doors. In our add on visited, we need a new input direction. And that's going to be our E direction. We also need another array to add that to. Call this neighbor direction. And that's going to be an E direction, but it's going to be an array. And we'll get that here. We want to set array element. Our index is this value here, and our direction hooks up to item. Save. In our execute with context, we also want to resize our neighbor directions array. Let's get that here, and let's resize that as well, the same size. That way both of these arrays are matched to the size of our points array. And so for that, we also want the length. Where we're calling add unvisited, now we need to set the direction. This is going to be north, south, east, west. When we find our east and west direction rooms, we look at this grid here. This is how our indexes in our array map out. We're at this cell number 4 here, and we subtract 1. We actually wrap around to 3. And this actually isn't a valid west neighbor, but in this function, it appears to be. And then the same thing happens here at 7. When we add 1 to get the east neighbor, we go to this one, which isn't a valid east neighbor. And this creates issues, obviously, because we're going to get a doorway between those rooms that don't actually hook up. The way we're going to fix this is by using a modulo function and using this max y. What modulo does is when you divide a number by another number, if that number does not divide evenly, modulo will give you the remainder. So if we take our room index and we do a modulo with this max xy, it'll determine if it lined up evenly with our size or not. To do that, let's first truncate this, just like we did with the x. Then we want our modulo function, which is denoted by percent. We can find that here. In the case where we're subtracting 1, we want to make sure that this value here is not even. So in modulo is not 0. So we'll do a does not equal, and then we're going to take that into a branch. And that's for this one here. So we're going to connect this up. And the other case is this one here when we're adding 1. And what we want to test for here is the case where this modulo is not equal to, in our current case, 3, with our row size of 4, but we want this to be generic. So what we want is do this truncated value -1. So if that's our return value, then we need another branch going into there. And that'll remove those erroneous east-west passages. And back in our visit room, now we know what direction these are. In get neighbor directions, get a copy. Want to use this index. That should give us the direction of this room. Okay, and then we just need to add a door between current room and the selected room. Let's create a function for add door. And we want 2 inputs. Both of those will be integers. Current room and neighbor room. And then we'll also want to add the neighbor direction. So in order to add the doors, we're going to need to add our north, south, east, and west doors to our points. We need to go back to our execute with context, and we need to set up our output points. Let's make a little more space right here, and we'll disconnect this, and let's promote this to a variable. Call that input points. And then after we set input points, we want to construct object from class. And the class we're creating from is PCG point data. I'm going to do that right here after input points. And then let's go ahead and promote this to a variable. Call that output points. And then we want to initialize from data. And our source data is this input points. Let's get input points. That'll copy our input points to our output points. And then we need a mutable metadata. And the target is output points. And then to this, we can add those new north, south, east, and west. Those are going to be Boolean attributes. Create bool attribute from PCG metadata. And then that attribute name, I'm going to call this north door. Default value is false. Move this all up a little bit, not hitting that comment. And we're just going to copy this, make 4 of them. Hook those all up. North, east, south, and west door. And then after that, we'll continue back into where we were before with our room points. So now we have those attributes added to our output data set, and our output data set is a copy of the input data set. Let's make a little room after our metadata, promote this to a variable, call that metadata, look that up. Now with output points, we can add those doors. If I just call these northeast, southwest, instead of having door on there, we can just use that same enumeration name and turn it into a string to line up with these. That makes it a little easier. So let's go back into add door. So what we end up wanting to do here in add door is we want to get our output points, and then we want to get points from that. And then we're going to promote that to a variable. I already have it here. And we're going to set that to output copy. We have a copy of our actual points this way. And then we're going to modify this copy, and then we're going to set it back into the output points. So to do that, we're going to want to get reference for our current room point. And then from that, we're going to set Boolean attribute. The attribute we want to set is our neighbor direction. We're going to convert that to a string with enum to string, and then we'll convert it to a name by dragging it up to the name. We'll need this output copy over here, and then we'll get from that, get a reference again, and we'll connect that neighbor room up. And again, we'll do set Boolean attribute, up that point, and then we need to get our metadata, drag that in, hook up the metadata. And for our neighbor room, the attribute name we want is the opposite of this name. So we want to do that with a 3 select. Hook it up here, and we'll grab this enumerator here, hook that up to our wildcard, and then we want to set these to be the opposite. So north is south, east is west, south is north, and west is east. Then we want to set this back to our output points. Get your output points, and then use set points. And we'll set output copy as our endpoints. We want to make sure we check this value here on both of these because we want to be setting that to true. Compile and save. And if we go out here to PCG level and we debug this, we should see a variety of trues and false here added to our data or add doors, showing that it's working right. I found a bug. I noticed that sometimes not all the rooms are being visited. I found that by looking at PCG level, we look at our add doors and we look at all our doors here, we'll see that sometimes we'll have an entry like this, where we have false, 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 false. And here we have 2 of them in a row. There's no trues in that. So no doors got added to room 10 or 11. And that shouldn't happen with the maze algorithm if it's working correctly. So this indicated to me that there is an error. So I started looking, and what I found is in visit room inside of our add doors, I added a couple of debug prints. I had a feeling it was this random integer in range that's causing the problem. So I added a debug print here, and I created this little function that just prints out the name that I give it and the value that I give it. It's a very simple debug print, and I added that right here after the get, and then I added it here before the call to add door. And in theory, these values should both be the same. So it's coming off this get here, and it's this line right here, which is all the same. When we compile this so that it runs and we look at our output log, which is where this is all printed, it's printed to the screen too, but it's too fast. And I have some other prints going on here as well. But here we can see the get, and here we can see before add. The get shows 11, before add shows 14. This is what's causing our problem. Sometimes it's the same, get is 10, before add is 10, but sometimes it's different, like this first one here, 11 and 14. So that causes is visited to get marked to 11, but the actual door gets added to 14. And so that isn't going to work. The way we fix that is to disconnect this random in range, and let's promote this to a local variable. Call this selected index. And let's hook that in right here. After we push current room back onto the stack, and then we're going to use that selected index here instead of using the value from the random in range. That way, this value is only set once right after this is called, and then whenever this is accessed, it's going to get the selected index that we set. So now, if we look at our output, and the easiest way to do this, clear the output log, file, and then look at the output log. So we'll see here our get is 9, our before add is 9. Get is 13, before add is 13. Get is 14, before add is 14. And so now we're getting consistent results and that value isn't changing. So that's working correctly. And if we look at our PCG level, we should see that all the rooms are now set with at least one door. And we do see that to be the case here. So that fixes that problem. Now I'm just going to remove these debug prints and the other ones I have in elsewhere and clean this up. Just for informational purposes here, I'll also put in some prints here after the while loop, taking a look at the visited array and the stack. How I did that is set up a debug for an array, and that looks like this. Just prints out the name of the array, and then it loops through the entire array and prints out the index and the value of all the array elements, and then it returns. And I also did a print array bool. So that's similar, but just with a Boolean array instead of an integer array. And those are what I used to print out here. I print array bool, printing out is visited, and I have the debug print array printing out the stack. And when we looked at the output log, that's what you're seeing here. This is visited, showing the initial values being false everywhere except for room 10. So we started in room 10. And then we see the stack has just room 8. But hold up, those two values should be the same. I think we're having the same problem here with this random in range. We're setting is visited right here, and then we're pushing onto the stack the same value, but these are both coming off a random. So I think we need to promote this random in range to a local variable. We'll call that initial selected. And we'll set that right here before this set array element, and then instead of using the random, we'll use that value. And we see those other prints. Then here again, visited and the stack, visited and the stack. So if you set something up like that for yourself in a complicated system like this, where a lot's happening that you may not be able to visualize, it helps you see what's actually happening and the changing in state that's going on while it's looping. And obviously there's a lot of data that gets created. So this can be very helpful to get through everything and debug it. So the next step, we need to actually make use of the north, south, east, and west data that we've added to our PCG add doors data. We have our north, south, east, and west data here, and we need to parse this data back out where we add those doors. So if we go inside of our loop subgraph PCG room 1, where that data is used is here in PCG get centers. We look in get centers here, we use our north, east, and west, and this is getting the attribute from our blueprint, which we're no longer connected to. So these are all erring, and we're not outputting any doors. So we need to take this data here instead from our center data where it is and get it into these branches. So let's make a copy of our PCG get centers. We go out here to PCG get centers, inside our PCG functions, and copy this. And we'll just call it PCG get center 1, or you could call it PCG get centers doors or something like that. I'm just going to use 1, and we go back out here to PCG room 1. Let's now change this to use that version. And then if we click into this, we'll be in get centers 1. That's good. We'll close this other one down. And here, instead of this get attribute, what we want to do is get attribute from point data. Can find this by grabbing our point data and connecting, and then we get attribute from point data. And for this attribute, what we want here is our input source to be north, and our index is 0. That's fine for our purposes because we've split this out, so we're only looking at one set of data here with our centers. Remember, this centers is our data for each individual room that's getting looped through inside of our PCG room 1. PCG level, we're looping here through our attribute partition data. We created the data, we added the door data to it here, and then we split that into individual data here with this attribute partition, and we're looping through each of those. So in get centers 1, we only have one set of data here to look at. So we can use index 0, our input source as north, and we need one of these for each of these branches here. So this first one will be north. And we need to hook this up to our output to B and replace that connection that we had before. And then we're going to copy this for each of those. And we'll have north, east, south, and west. And we'll hook those up in place of here, and we'll hook these in as well. And maybe it's better if we grab off of these ones that are going down here already. And if you pause your regen here, then it'll stop regenerating every time you change something. It'll go a little faster. And we'll need to make a little space to hook all that up. Then we can unpause our generation, save that, and we can take a look at what we end up with. And we can see we have a couple of problems. One of our problems is that we're seeing doors on our outside, which we shouldn't be seeing. The other problem, if you look at one of these interior doors here, we see that there's both a door and a wall here. So we need to figure out what's going on there, and our bookcases are in front of our door. So another problem that wasn't readily apparent in the initial looking at this happens when we change the number of rooms. So right now we're looking at a completely square grid. Our rows and columns are equal. If we change this to a 4-1, we end up with no doors at all, which is strange. There should still be doors. And if we go to 4-2, we end up with some rooms that have no doors. And this is actually easier to see if we go to PCG level and we inspect the output from add doors. We can see that there are rows here that are false and have no doors at all. And as I noted previously with the maze algorithm, every room should get visited and every room should end up with doors. This is definitely an indicator that something is wrong. And the reason this happened is because I've been testing with a square grid. And what's happened is I actually have the columns and rows swapped and didn't realize it. We go into find unvisited neighbors inside of add doors. We're using the X value here to determine our north and south and our Y value for the east and west. So that says that the Y should be our rows and our X should be our columns. But looking at the reality, that isn't the case. So if we debug, we add a breakpoint here on the sequence and then we compile so it'll stop here at the sequence. And then we step through, we can figure out where this is failing. So we need to step in here and we look at the valid values here. And what's happening is that this first branch was false. So this is saying that the value isn't valid. And what was that value? That value for this index is -1. Okay, so we're taking the room index of 3 and we're subtracting off a value of 4. That value of 4 is the maximum X. So that maximum X is this direction, this 4 direction, which if we're in room 3, so this should be 0, 1, 2, 3. So we should be here and we should be subtracting to go up to here. We want to go from 3 to 1 to get this direction. So what we should be subtracting off is the row size, but we're subtracting the column size. So hopefully that makes sense. So if we subtract off 4 from this, we're going way up here. That's not right. So we want to be subtracting 2, the previous 2 rooms, to get to here. And that's our row size. So what we should be subtracting here, this value subtracted and added should be our row size, which is Y, not X. And so I have these 2 values flipped here. So let's fix that. We'll stop this execution and we'll take these values up here and this value down here, switch these around. And now, if we debug again, okay, we see we're looking at a room index of 7. So 0, 1, 2, 3, 4, 5, 6, 7. So we're looking at this room here. So to go north, we should go to room 5. We should subtract off 2. So if we subtract here, not showing our value, step in, and now it's true. I think that's correct. Step out. We're still on room 7. So this will go here. Okay, now it's showing the correct value there. So look up there, it's 5. This value probably doesn't show, no. Let's step over this. Now it should show that value. That's showing 9. 9 would be down, and that's correct. And then these values here, so let's see. That says true. That says true. 7 add 1 is 8. This should not be true. Something got messed up here. This is showing -4 that we're comparing to. Oh yeah, I hooked this up wrong here. Okay, whoops. This should be hooked up here. So this was supposed to be our size -1 compared against our modulo. And this modulo is the one comparing against 0. Run this and see what we end up with. We're definitely getting doors in every room now. Still getting these exterior doors we shouldn't be getting. But I think there's another explanation for that. Refresh this. Every room has doors. So that fixes that first problem. And if we go down to a size of 4 and 1, okay, so we have doors. They're oriented the wrong direction. So this door here should be going up to this room here instead of out. So this is showing what our problem is. It's orientation. So these east-west doors are actually should be north-south doors. In order to get our orientation right, let's try looking at a very simple case. I've set this to a level size of 2 by 1, and we're seeing 2 doors here. These doors should be in the middle going this way, but I've got one going north and one going south off this room, or perhaps it's the opposite of that, north here and south here. But anyhow, I believe this is room 0 right here. To prove that, let's take a look at positioning Manny into that room. We'll grab a Manny here, just drag a mannequin mesh into your scene, and then we can position him. I'm going to put this at -900 by 0. And if we look at PCG level and we look at our doors, we should see -900 by 0 is room 0 and 900 by 0 is room 1. And we see we're asking for east and west, but we're getting what appears to be north and south. So we're rotated from what we want this direction. So let's try going to get centers, and we'll move these by 1 position clockwise. North becomes east, east becomes south, south becomes west, and west becomes north. Let's take a look at what we ended up with. And that is correct here. Okay, so we have our east-west passage between these 2 rooms. So now let's switch that orientation. So looking at a 2 by 2 case now, I've got Manny here in room 0. It looks like our north and south are flip-flopped. We're getting an east-west room here, which looks like it's working correctly, but we're getting doors down this way and up this way. So I'm going to try switching north and south here. Negative y and positive y. And I think that's going to get our doors on the inside. So now in this case, a 2 by 2, everything's working. Try a 3 by 2, and we're still seeing exterior doors here, so something's still wrong. So that room, this room, seem to think they can connect to each other maybe. Find room 0, 1800, 900. This is 0. 0 should have an east and a south, and 1 is at 0900. Next one over. Okay. So there should be, yeah, so these are correct. The door here, right? Yep. So those are as expected. If we look at 0, 1, 2, room 2, it's going north. Room 2 shouldn't be able to produce a north door. So we should be subtracting 3. Where's our X and Y? We're 3 by 2. Oh, because of our switch in orientation of our north and south, our X and Y are now flipped again. Have we done it? Let's reverse this. 2 by 3. Now we have the issue this direction. The correction for this turns out to be that both of these should be off the X, and we don't use the Y because the X is our current row size. We want to both subtract or add the rows to go north and south, and we want to check against the row size with our modulo to determine if we can go east or west off the edge of the board or not. And the X is our current row. Okay, so we have everything corrected here with the orientation of our doors. You can see we no longer have any doors on the outside. We have doors connecting all the rooms together, and our doors match what we're seeing here for our north, south, east, west, and our points. So everything is working correctly as far as that's concerned, but we still have another issue that we need to address that's pretty important. And if I hit play, I'll show you what that is. We come in here to a room and we open a door. Okay, that one works fine. Some of them work, but others, we'll see the issue. There it is. There are 2 doors here. So what's happening is if we look at the top of our wall as well, we'll see this flickering. And what's going on here is we have 2 walls between these rooms. Because we're creating a full room for each room, we're creating all 4 walls for every room. And so on the intersections, you get a double wall. And when we put the doors in, we also get a double door. So we need to eliminate one of these walls in here. And we can do that by subtracting out those points. So let's take a look at how to do that. So what we'd like to do to fix that is somehow pass our door points from one iteration of the loop to the next iteration of the loop, and do the same thing with the walls and exclude those points from, for instance, loop 0 from loop 1 and from loop 2, etc. But unfortunately in Unreal 5.3 there is no mechanism to pass those points from one iteration of the loop to the next. So what we're going to do instead is we're going to output these points from walls and doors, and we're going to deal with it outside the loop. So what we want to do is break our static mesh spawner connection, and we're going to add an output node instead. And on the output, we want to add a new custom pin, wall points. We're going to make that a point type, and we'll add that return node. And we're going to do the same thing with our door points. I'm going to break this spawn actor, add door points, bring this up there. And then these 2 nodes I'm going to cut, save this PCG room 1, I'm going to go out to PCG level, and I'm going to paste that back in here. With our wall points, we're going to do a union, and we're going to do a self pruning, and then we'll take that into the static mesh spawner, and we'll do the same thing for our door points. The reason we're doing a union here is because we have these multiple sets of data coming out. We have one set of data for each room, and when we union those, we turn that into one combined data set, all the points in it, and then we can do self-pruning to remove those duplicate points. And that should fix our dual problem. It looks like it also causes some issues here in the corners, so we're going to have to resolve that. That might be a steepness issue. Take a look at that. But I want to make sure our doors are working correctly, so let's hit play. Let's test a couple of doors, and we should now only have single doors at each intersection. And when we look at the top of our walls, we don't see that flickering anymore. We're not having that fighting of having 2 walls here. So that is working correctly, and we just have to solve this issue of these points being lost. Turning our debugging on here at the union will let us see those points. And it looks like this point is hitting this point, and that's probably what's causing this one to get cut. And if we look inside of our loop subgraph, we can see that we are setting the steepness to 1, so it's not a steepness issue, it's just that those points are touching. If we just shorten that point here a little bit, and that might actually be more than we need, we'll see those walls pop back in here. And we have that problem solved simply and without having to upgrade our version of Unreal. At this point, we have part 4 working as intended. There's still a few more items I'd like to cover, but since this video has been pretty intense and is already about an hour long, I'm going to break the remaining topics into a part B. In part 4B, we'll cover randomizing our room types, adding extra doors for some added variance to the maze, and adding ceilings to our layout. That part has already been created, so it should be available in about 2 weeks, or sometime next week on Patreon for my supporters. As always, please subscribe for more content, like the video, post a comment if you have a question or issues, and feel free to join the Discord. If you're able to support the channel, please join my Patreon or buy me a coffee. All the links are in the description, and I'll see you in the next video.